Okay, let me introduce myself. My name is Eva Satmari. I am the school's Mathematics and Statistics Learning Coordinator, Learning Support Tutor, Support Lecturer, whatever you want to call me. The important thing is that while you're studying here, I can be your first contact anytime when you have got problems with mathematics around your courses. That's not just for first year, that's throughout all of the 3, 4, how many years you are here, okay? My email address is here, and that's my phone number, okay? Unfortunately, I will be on maternity after Christmas. Somebody else will be taking over, but we don't know yet who. But somebody will be around to be able to help you for the rest of the academic year. If you have got any questions up until Christmas, you can come and see me. After that, it's someone else, and I'll be back kind of September. So, what we're going to do today, I'm going to show you a little bit about how you can get further support, not just by contacting me, but online and the rest of it. We're going to cover a little bit of negative numbers, then how to write algebraic expressions from text. Then we're going to go into expansion of brackets, factorization, calculating values of expressions, creating formulae, and if we have got time, I'd like to go into a little bit of on exponents, just to sort of try to cover as much as possible. I have no idea how much algebra you actually need on your specific course. It varies by different modules. Some modules don't use maths at all. Some modules have got quite a few complex mathematics on it. So that's going to be a sort of personal decision. So the main role of my job is providing one-to-one support. So if you have got questions and there is no workshop around that types of questions, you can always get in touch with me, and we can organize a tutorial which usually lasts no more than an hour, and it's maximum 1 a week. But even that, we don't really like to have it be more kind of constant support, sort of 5, 4, 7 weeks all in one go, because that's sort of indication that there might be some serious skills lacking, so you probably need to go and do some more study. I also have got a Moodle site, and you should have access to it automatically because everybody in the school is automatically enrolled to it. So on that Moodle shell, I put up a lot of useful videos, support resources, and all kind of different things. That's where this video will go as well. And if you just want general mathematics information, just sort of a short recap on certain topics, the mathtutor.ac.uk is a really good site to start with. That's been put together by UK higher education support lecturers, tutors like myself, starting from basic arithmetics all the way to calculus. There is another website that students quite often use, and that's the Khan Academy. Now the Khan Academy starts even more basic than the math tutor, because that's basically start from number facts and everything, and it's probably goes up a little bit higher than the math tutor goes, because it has got linear algebra and all sort of other mathematical topics. The difference between the two, the Khan Academy has got, it's an American to start with, so the accent and the examples might be slightly different than the notation and the rest of it. And on top of that, the Khan Academy, the videos is usually 10-15 minutes, so it's more like a dip in, dip out. If you've got one small question, you want to see a couple of examples, you can go in there. On the math tutor, you have got videos which are more or less around 30 minutes, roughly, so it goes into details a little bit more, and it sort of starts from basic knowledge and build up from there. While the Khan Academy, it sort of dips in and dips out. Not everybody likes Khan Academy. Some people prefer the maths tutor, but that's again personal preference. So those two are always good to start with. If you find that some topics are a little bit difficult, or you don't know what to do with them, you can always go there. Oh, one thing, if you can't organize a one-to-one tutorial and come in person, and you don't really have time for Skype tutorial either, you can always just drop me an email. So you come across a mathematical calculation which you don't find the solution for it, or you went somewhere wrong because your solution is not the same as the expected solution, then what you can do, either take a picture or scan that question and your solution, send it to me, and I can send you back an email and comment on this is what should have been done, or this is how you could solve the problem. So that's an alternative to coming in and organizing tutorials. So, negative numbers. When adding and subtracting negative numbers, what do we know about that? Generally.
Just the basic rules like minus, plus, minus, plus.
Is that always true? Then adding and subtracting them? For example, if I've got minus 2, add 5.
There you go.
Hello.
If you have the line, then you can go up the line.
Ah, okay. So yes, you can use the number line to call as a visual help. So if you've got the number line, here is your 0, minus 2, oops, would be somewhere here. And then if you need to add 5 to it, adding is making something bigger, so you would move this way 5 direction, and then you would end up in positive 3. That's how you can use it. But just by looking at them, you can't always say if it's positive or negative, the same way as you would be able to do with multiplication and division. Because in there, the same signs makes positive and the different signs make negative. Here, it also depends on the magnitude or the size of the number. So usually the rule is look at the two numbers, ignore the sign, and see which one is bigger. The 5 is bigger, so your result will be positive, and then you just subtract them. So that's the general rule of how to work out additions and subtractions with negative numbers. For example, if you had something like 3 minus 7, then when you look at 3 is obviously positive because there is no sign in front of it. That's always for the positive numbers. Out of the two, the 7 is the bigger, so the sign will be negative, and the difference between them is 4. So that's another way of remembering it if you don't want to jump up and down on the number line. Another very useful way is to think about negative numbers as debt. Because, you know, in everyday life you are very used to how to manage your own finances. So you always know that if I have a debt and I'm paying more money out, which is taking away, I'm going to get into even bigger debt. And, you know, if I have got debt and got money coming in, first I need to pay off my debt, and then I can go into positive if I have any money left. And yes, there is a number line as well. So, if you want to, feel free to use the number line, which is down there. Well, what would be the solution for these calculations? So the first one is 4 minus 10. What's the answer to that? Minus 6. Okay. Minus 6 plus 8 would give you positive 2. Minus 4 minus 5. Minus 9. Minus 6 plus minus 7. Now, when I have got two signs in here, that's again where your note about positive, negative makes negative comes in, because I'm adding a negative number, that's the same as taking away the positive. So I can write this as minus 6 minus 7. And you might be able to see this way easier what's going on. So I was already in negative, I'm going further down in negative, so I'm obviously going to end up with negative numbers altogether. But what will be the answer? Minus 13, yeah. And the last one, minus 7 minus negative 4. When I have got a negative and a negative together, taking away a negative number is the same as adding a positive number. So that's just normal addition, and that gives us positive 11. Okay? Now, these ones should not be too complicated, but it does trip up people here and there. Now, when you're multiplying and dividing, the rules are much, much simpler. Basically, the ones that we used in the last two examples. If your rules are, if your signs are the same, the solution will be positive, regardless if I multiply or divide. And if the signs are different, the solution will be negative for both multiplication and division. So, when I have got these examples, I don't need the number line anymore. So when I have got these examples, minus 3 times minus 4 gives me the positive 12. Minus 20 divided by the minus 4. Positive 5. Oh, there is no minus in there, sorry. Negative 5. I should be looking at the screen, not just making up examples as I go along. So 16 times minus 8. Now it's times. It will be negative for sure. 10 times 8 is 80. And 6 times 8? 48. So that's all together 128. Okay, and if you don't have a calculator, this is a good mental arithmetic method. Bring down the double-digit number into 10 plus 6, and then just multiply each of them by the 8, which gives you 80 and the 48, and then you can add them together. Slightly faster if you're good with your times tables, assuming you know 6 times 8 quite quickly. Where were we? Okay, minus 20 divided by minus 5. Yeah, that is plus 4. Oops, not 5. Okay, next one is 25 times 5. Again, you can break it down 5 times 20 and 5 times 5. That's not good. That's not 75.
Is that 125?
That's 125. Because 20 times 5 gives you 100, and 5 times 5 gives you another 25, so that's 125. And 144 divided by negative 12, the solution will be negative, but negative what? 12, because 12 squared is 144. So 12 times 12 is 144. Now, again, most likely in an exam situation, you'll be able to use a calculator. I suggest that you get hold of one of the scientific calculators. And I also suggest that you know very well how to use it. Okay? If you haven't used the scientific calculator since high school or secondary school, it can be a little bit tricky to get back into it. But we put together some quick video reminders on how to use the scientific calculator, which is up on the management library website, library guides. Management, there is a video tutorials on calculator use. But I think I put a link to them on my Moodle site as well. So you should be able to find them one way or another.
Can we download the scientific calculator on our phone and use our phone or no?
Phone, no. Exam, you're not allowed to use a phone. Every phone nowadays has got the scientific calculator built into them. In most cases, if you come up with the calculator and you turn the phone this way, the scientific calculator appears, but you're not allowed to use a phone in the exam, simply because that phone has got internet access, so you would be able to use it for something else. So if you need use of a calculator in the exam, you have to take in a scientific calculator, a manual one. Otherwise, you have to do it by hand, which probably takes quite a bit of time. Okay, so that's just a quick recap of what's going on in them. But another important thing about mathematics is that mathematics is a language. So you just have to be able to write and read that language as well as any other foreign language that you need to learn. And for that, we need to be able to distinguish between certain words, everyday life meaning and mathematical meaning. So I would just like to give you a little bit of taste of what that is like in this slide and probably the next one. So these are two business examples. So you were given that the total revenue is calculated as price times quantity. Now in mathematical way, we don't writing out long sentences, but we want to be able to formulate it in a condensed and straightforward way that everybody would understand what we're talking about in here. So whatever you study, whatever subjects you study, it will have some specific vocabulary. In this case, total revenue is something that we need to know, and total revenue is usually represented by TR. Now in mathematics, sometimes when we just write two letters one behind the other, we usually automatically assume that the two letters are multiplied together, unless they carry some specific meaning, which in this case they do. So be aware of those notations in your own field, because sometimes the two letters might mean you need to multiply the two quantities together, but sometimes it just means one specific concept. So be aware what's going on in here. So total revenue, price is usually represented by capital P, sometimes small p, depends on the context. And quantity is usually represented by capital Q, but sometimes lowercase q as well. So question is, how can I write that sentence in the language of mathematics? Well, total revenue is calculated as, that's basically another way of saying in mathematics that it has to be equal to price times quantity, that is just price multiplied by the quantity. So if you see a formula like this, that's basically absolutely the equivalent of the sentence above. So similarly to number 2, total cost, that is represented by TC, and again that's not multiplication, can be calculated as fixed cost, which is capital F and capital C, and the multiple of the variable cost, which is VC, and quantity. Now I have got the word and there twice, and if you look at it from closer, the and has got a slightly different meaning in the two cases. Because if you look at here, the total cost can be calculated as, that is this part, total cost equal fixed cost and the multiple of the variable cost and quantity. So the first and here connects together the fixed cost and the other two quantities, but this first and is an addition, while the other end actually comes together with the multiple of and. So this and here is linking together the two quantities that you need to multiply together. So that is not addition there, because that's part of the multiple of expression. So the multiple of the variable cost and the quantity. That's basically, you have to multiply the variable cost and the quantity together. In very often you just see the formulae, but in some text explanations and so on, they try to explain them, so it's good to know the little bit of variation in the language as well. Okay, some more business examples. I have a budget of 2,000. I will spend it on books and laptops. Books cost 330 each, laptops cost 450 each. Express my budget in terms of books and laptops. Now what they're actually asking us is that we need to come up with a mathematical formulation or mathematical equation or a formula that would encapsulate all the information I put up there in a short way. Now, budget in mathematics, in business and economics is usually represented by capital M. Okay, that's quite common. Now, books and laptops are my variables because those are the quantities, those are the products that I can buy. Now, I have got a choice what I want to name them. I can use them quantity 1, quantity 2, because that would be the number of books and the number of laptops, if I wanted to. However, I think in this specific case, I will choose B for books and L for laptops, because that way it's easier for me to remember which one's which. Because if I just put there Q1 and Q2, I might mix up the prices and the corresponding products. But in most cases, in these situations, if they don't specify what is product 1 and what is product 2, you have got the choice. So you can choose whatever is easier for you. Now, books cost £30 each and laptops cost £450 each. So that tells me that the price of the book, which I can call PB, is 30, and the price of the laptop is 450. Now that is one laptop costing 450 and one book costing £30. Now, without me going to before we go into the formula, how would you actually calculate, how would you think about the situation in an everyday life scenario? So you've got £2,000, you want to share it between books and laptops. So if you buy one laptop, that would cost you 450. If you buy two laptops, how much would that cost you? 900, double of that, and three, triple of that, and so on. Similarly for books, one book would cost you 30, two books 60, and so on. And together, when you add them together, that's when you can compare if you went over or you're still under your budget. So that kind of gives you, more or less, the mathematical formula. Because you know that your budget has to be equal to the sum of what you spend on one product and the other product. And I don't know how many books I buy, but I know that each of them costs £30. So if I buy a number of books, they would cost me 30 times that number. And if I have got if I buy the laptops, they will cost me, each of them, 450. So a number of laptops times 450. Now, if I wanted to write this up without the actual prices, the more generic formula would be price of book times the book, numbers of books, and price of the laptops times the number of laptops. I could have actually chosen this one, probably in a more generic scenario, you would have chosen QB and QL, quantity of books and quantity of laptops, numbers of books and numbers of laptops. That's very common use of the, that's very common use in business as well. So this generic formula, then you might come across with price of B times quantity of B plus price of L times quantity of L. That's probably more familiar if you study business. But as I said, you have got a little bit of freedom when it comes to choosing the notation if it's not specifically given to you. Okay, next example. A £10 note gets changed into 1 and 2 coins. How many of each we have if we get 9 coins in total? Again, we need to kind of formulate it into the language of mathematics, into symbols, to be able to do anything with it. Now, what I know is that I have got £1 coins and I have got £2 coins. Do I know how many I've got each? I don't. But I can assign variables to those. So I can say, okay, I might have got X number of £1 coins and Y number of £2 coins. Now, what do I know about the number of coins? Well, I know that the number of coins in total is 9. So I know that X plus Y have to be equal to 9, because the number of them is 9. Now, that's good for me, but bad for me at the same time, because I've got now one equation with 2 variables. That can't be solved. If you have got one equation and 2 variables, you have to have at least another equation, some more information, to be able to solve it. So what's the other information that we can take into account is that I started with a £10 note. So that £10 have to be equal to the value of the £1 plus the value of the £2 together. So I've got X number of £1, each of them worth £1. So I've got 1 X times 1 or 1 times X, which is just X. But I've also have some number of £2 coins. And every £2 coins, the value of it is double. So it would be plus 2y. Because if I have got 3 £2 coins, that would give me 3 times 2, which is 6. So now I have got the 2 equations and the 2 variables. And I can do something about it. We're not going to do anything about it today because solving equations is a different workshop. But if you want to learn about how to solve these systems and can't wait until the next workshop comes up, go to Maths Tutor or the Khan Academy. Okay? So this is about how you formulate the problems in the language of mathematics so you can start and solve them. Right, let's do probably the main bit, which is now down to the algebra. Now, expansions of brackets, basically what we need to do here is multiply out the bracket. So, if I have got 2 terms in the bracket, that tells me that this 4 in front, I need to multiply everything inside the bracket with that 4. There is no sign here, so that's always multiplication. So what I need to do then, it's relatively simple. So 4 times x plus 8 will be equal to 4x plus 4 times 8, 32. And the 2 expressions are absolutely equivalent. Sometimes you do backwards because you want to sort of simplify. Sometimes you simplify it this way. So it really depends on what kind of manipulation you want to do. So a times a minus 2. Same rule, multiply everything inside the bracket with a. A times a gives me a squared. That is the shorthand. The power notation is always telling you how many times you're multiplying the same base by itself. And then a times minus 2, that's minus 2a. Again, in mathematics, we like to have the numbers first and the letters second. But I could write a2 as well, not very common. But because multiplication is commutative, 2 times 3 is the same as 3 times 2. The 2 expressions would be equivalent, but this is what's more common in mathematics. So same, minus 2 times 4 gives me the minus 8. Minus 2 times minus 3b gives me the positive 6b. Negative times negative gives me the positive. And the last one, x times x gives me the x squared, and x times minus 2 gives me the minus 2x. Then I've got another bracket, which I also have to break up. Minus 4 times 5 gives me minus 20, and minus 4 times minus 3x gives me the positive 12x. Now what I can see here now is that I have got terms that are the same, because I've got here minus 2x plus 12x. So I can combine them together, and together they would give me positive 10x. It's like I'm owning you 2 apples, and I gain 2 apples somewhere. I give the 2 to you, so I still got 10 of them. So altogether, the expression comes as down to x squared plus 10x minus 20. And that one is a lot simpler than this one. You can easier see what's going on in here. Any questions? Now another type of expansions, when we have got 2 brackets but now we're multiplying them together, and each of the brackets have got more than one term in them. So the first one is x plus 3 times x minus 3. Now what is the key here is that again you multiply everything by everything. Some schools might have taught something called the FOIL, which I always forget what stands for. First, inside last, something like that. If you just Google FOIL mathematics, you'll find the exact expression. What I remember and what I usually do is I write arrows on top what I'm doing, so I can keep track of which one I multiplied and which one I still need to multiply. So I need to multiply x with x. That gives me x squared. And I need to multiply x with the minus 3. That gives me minus 3x. And then I multiplied x with both of them. Now I need to move on to 3. 3 times x is 3x. And 3 times minus 3 is minus 9. Now, what can you see here? Negative 3x, positive 3x. What is that going to come down to?
0.
They cancel each other out. Positive of the same thing and negative of the same thing always gives you 0. So what I actually ended up with is x squared minus 9. But hold on. That is the square of the first minus the square of the second. So, next time, if you see a bracket where there are 2 terms, but in the first or the other way around works as well. If in one of the brackets they are a sum and the other bracket they are a difference of the same 2 terms, that's always going to be equal to the square of the first minus the square of the second. And if you remember this algebraic, I don't know what you call it, rule, probably, you can skip the multiply everything by everything and can just write up this solution straight away. So in a situation when you need to do a lot of algebraic manipulations, it pays out to know these algebraic expressions or algebraic rules, because then you can get to the final answer a little bit quicker. Next example, 2a minus 7 times a plus 4. Now, unfortunately, all over the place, everything different, so there's no shortcut here. We have to go through, multiply term by term. 2a times a gives me 2a squared, and 2a times 4 gives me 8a. Then I've got negative 7 times a, which is minus 7a. And I've got negative 7 times positive 4, that gives me negative 28. So again, what I can see is that I've got plus 8a minus 7a. That's nicely cancels down to positive a, one of it only. But the other two terms are very different, so I can't do anything with them. Important thing is that a squared is very different from a, so I cannot combine them together. I have to keep them separate. So as soon as I start to have powers of the same variable, the different powers, I have to treat it as a different variable. Next one, 4b minus 2 times 2b plus 4. So again, what I need to do, term by term. 4b times 2b, I can multiply the numbers together separately, that's 8, and I can multiply b by b, which gives me the b squared. And then I've got the 4b times the 4, that gives me positive 16b. Then I've got minus 2 times positive 2b, that's negative 4b. And minus 2 times positive 4, that gives me negative 8. And again, well, I can see that I've got positive 16b and negative 4b. So that altogether gives you positive 12b minus 8. And not forgetting about the square term, because that again can't be combined with anything else. What we are doing here, when you kind of bring them together, combine them together, it's called collecting like terms. So if you want to do a bit more practice on that, you might want to look for that term. Okay, last example. X plus 4 times 3x plus 5. So x times 3x gives me the 3x squared. X times 5 gives me the 5x. 4 times 3x gives me the 12x. And 4 times 5 gives me the 20. X squared is just one term, so I can't collect it with anything else. 5x plus 12x gives me 17x together. And again, there are no more separate numbers, just the 20, so I can just write that down. Any questions? Clear enough? Now, these rules are good to know because, as I mentioned just about a few minutes ago, if you know them, they make your life easier. Okay? You can always derive them from the fact that x plus b squared is nothing else but, a plus b squared is nothing else but a plus b times a plus b. So if you follow through this method that we've just done, multiply everything with everything, you're going to end up with a squared plus ab plus ab plus b squared. And obviously ab plus ab going to give you the 2ab. So that's how that's where it comes from. Same here, but remember now, a minus b times a minus b. So a and b have got different signs, so their multiple will be negative. So in this case, I'm going to end up with a squared minus ab, which can collect to minus 2ab. But minus b times minus b going to give me the positive b squared. So that's why that's positive. And this one we already seen why it works. Okay? If you work with algebra quite a lot, these are very good shortcuts to have. Now, what we've just done, we were multiplying out brackets. The other way around, called factorization. So what you do in here, you look at the terms in your expression and see, are there any multiples there that I could bring out in front? So if I look at 8n plus 12, Well, I notice that both numbers, 8 and 12, are even. So one obvious way would be I could factor out 2. But can I factor out anything more? Well, I actually can, because if I look at both 8 and 12, it's in the 4 times table. So I can actually factor out 4, because 8n, I can rewrite 8n as 4 times 2n, and the 12 I can rewrite as 4 times 3. Now, if I factor out 4 from the first term, I have the 2n left behind. And if I factor out 4 from the second term, I got 3 left behind. So the factorization is the direct opposite of what we've just done. So we were multiplying them in, but now we're looking for a number that I can bring out in front of the bracket. And the key here, is there a common number or sometimes a common variable that I can bring out in front? Does that make any sense? Kind of. Okay. With mathematics, you have to look at and try a lot of examples to see how things in general work, and the more practice you do, the easier everything becomes. You can't learn mathematics reading from book, you have to do it. Now if I look at 4x squared minus 8x, what I see in here is that 4 and 8 both in the 4 times table, but also what I see, I know that x squared is x times x. So I can actually, the 4x squared, I can break it up into 4x times x, and the minus 8x I can break up as 4x times minus 2. And again, I can see that the 4x is a common term, so that 4x can come to the front, and if I factor this one out, the x is left, and if I factor this one out, the minus 2 is left. Until you become very familiar how to factorize things, it's always a good idea to check back. If I multiply these out, do I end up with the original one I started with? And in this case I do, because 4x times x is 4x squared, and 4x times negative 2 is minus 8x. So they are kind of doing the same thing back and forth. If I look at 5y and minus 45, that is probably simpler to see, because the 5y is 5 times the y, and the minus 45 is 5 times negative 9. And again, that gives me a common factor of 5, and that will be y minus 9. So factor out the 5 from here, the y left behind, factor out the 5 from here, the minus 9 left behind. Last one, 4x squared plus 2ax. Now, if I look at these two terms, I can see that both of them have got numbers, so I probably will be able to factor out the number. But what's the common factor of 4 and 2? 2. So I can factor out the 2 for sure. Is there anything else I can factor out? But I can factor out the x as well, because that is in both of the terms as well. So if I factor out 2x from here, I left an x behind. And if I factor the 2x from here, I left an a behind. So this can be rewritten as 2x times x plus a. Okay, are we happy with these? More or less? It probably puts you back into, I don't know, 5th grade, 6th grade. I don't know what year it's taught in the UK, but it's definitely been a long time ago. And if you didn't like it in the first place, you're probably not likely to want to go back there. Okay. Now, when we're doing breaking the brackets out, or multiplying the brackets out rather, we had the situations where we had two brackets multiplied together. Now, this is the opposite when you're factorizing the same thing. Now, if I look at this, well, I spot that there is a common a in the first three terms. But that's not going to help me because the third term doesn't, the last term, the fourth term doesn't have a in it. So I can't factorize a out from every single term. But what I also spot is that a is common in the first two, but c is common in the second two. So what I can do here is to factor out a from the first two terms. So I got left with a plus b, because a times a gives me a squared, and a times b gives me ab. And I can factor out the c from the second term, and that gives me a plus b back. Well, isn't that handy? Now I've got a plus b in both terms. So I can factor out the a plus b, and what's left behind is a plus the c. So this is how I can do it backwards, bringing it into two brackets. Oops, that's not plus. Ah. So again, what I see here is a is common in the first two, b is common in the second two. But I can also spot that x is common in here and y is common in here. So again, it's a choice of mine which factorization I go with first. The result would be the same. Maybe it's easier to see the a's, so I'm going to factor the a out, so x minus y is left behind, and then I factor the b out, so x minus y is again left behind, and that tells me that the x minus y can be factored out and the a plus b will left behind. So it's almost like this would be your 3 and this would be your 3 as well. So you just bring that 3 at the front and you've got the x and the b there. The last one, there's nothing common in here and I only got two terms. What's going on in here? Well, what's going on in here is that I can notice that this is basically a squared minus 3 squared. And now that is a difference of squares. And the difference of squares is always the sum. Oops, I should use the exact example here, not the generic. Is always the same as the multiple of the sum and the multiple of the difference of the two terms. So that is drawing on the fact that a squared minus b squared equals a plus b times a minus b. So if I don't know this, I'm not going to notice that it's happening in here and I won't be able to factor it out. And the last one That's again a tricky one, because seemingly there is nothing common. I can probably factor the x out from here, but then I would have x times x minus 2 plus 1. That's not two brackets. That's not factored out into brackets. So again, I need to draw back on my algebra knowledge, knowing that the square of a difference is equal to this. And I know that 1 is the same as 1 squared. 2 times 1 gives me the 2. So yeah, this is actually x minus 1 squared. Again, I'm not able to factor it out unless I draw back onto this sort of algebraic knowledge. So again, I don't know how much algebra you need to use in your module, but in some of them, you know, it's not really hidden algebraic knowledge, but sometimes it's actually quite difficult to sort of pick out what's going on in the algebraic manipulations. So, any questions?
I think you just have to practice it again and again and again.
Unfortunately, yes.
Yeah.
I mean, these 2 hours is so short, and I'm going through so many different topics. I mean, these kind of things you probably practice for at least a couple of weeks in school. So that's how you pick it up and become easy, almost like what we call it in Hungary a wrist exercise. So it just comes from writing it down. You don't even think about it anymore. But that only comes if you've done enough practice.
Could we do one more example of the last one?
This one?
Yeah, the previous slide, you did expansion of brackets. We have the x, this one here. And then essentially came to this term. It was like x squared minus 10x plus 20. Just trying to figure, because essentially like you could reverse and you wouldn't get this term.
No, because there are no commons in here.
Right.
I mean, for this ones, you can't really reverse it.
So you wouldn't be able to factor this one.
If I just looked at x squared minus 10x minus 20, I would not be able to factor it out back into this one, just by looking at it.
Or something different. You wouldn't be able to, not necessarily factoring out to this, but would it be able to be factored out into something?
I might be, because if I look at, give me the example again, x squared.
X squared minus 10x minus 20.
Because if I look at something like this, then I can see, okay, I can probably break this one up as x squared minus sometimes x, and then maybe 2 times x, and minus 8x minus 20. And in that case, the first 2, I can factor the x out, and I've got x minus 2. In the second, I see negative in both, and I see that the 4 comes out from both of them. So I can bring out the 4, and then you get the 2x plus the 5. So in that way, I could factor it out, but it's not the same factoring as it would be this, because in these cases, we all were able to break them out into 2 brackets. But these ones is the difference of 2 brackets.
Okay.
So that's slightly different. And strictly speaking, this one's actually more complicated to comprehend what's going on than this one is. But with these ones, you can sort of see, okay, is the multiple of the sum and the difference. That can be helpful if you need to interpret it. And again, here, what's going on? So, okay, it's a difference of 2 quantities times the sum of the 2 different quantities. So again, you can sort of think about what happens if one quantity changes, how does that influence the change of the overall, and all sort of things. Because probably in situations where you would need to actually factor it out is more likely when you try to make a complicated expression simpler, and then there might be some fractions at the bottom, or you have to get something else involved, or you're trying to come up with an expression for business concept or something. You're trying to relate one concept to the other, and then you're sort of trying to manipulate the formula up until you see that particular concept definition hidden in your formula somewhere, and you could interpret how the two concepts intertwine and those sort of things. So unfortunately, that's why you've been tortured with maths. Okay, the next topic is evaluating expressions. And this is sometimes called substitution. So it really depends on what your lecturer prefers to use. They either tell you to evaluate the expression, or they tell you substitute the values into the formula. Basically what happens in here is that you need to be able to you need to be able to swap the correct numbers for the correct letters and then carry out the algebraic calculation. So it's nothing overly complicated. I just need to remember that A is actually, in my scenario, is 5. So A gets replaced by 5. B is 1. So that gets replaced by 1. And C is 3. So that gets replaced by 3. And that is not an addition, that's a multiplication. Now, here you've got two choices. Either pick up the calculator, put it all in, and it gives you the final answer straight away. If you don't have the calculator handy, or you're not allowed to use the calculator, then you need to remember BODMAS. Now, anybody studied in this country? No? Oh, lovely. So none of you have ever heard about BODMAS then. Okay. B stands for bracket. O stands for other operations. D is for division. M is for multiplication. A is for addition. And S for subtraction. And this is a mnemonic. This is a short way of remembering the order of the operations. So it's telling you that if you have got a bracket, that's the one that you need to deal with first. If you don't have a bracket, then you need to deal with the other kind of operations. Now these are the kind of operations like squares, roots, exponents, logarithms, and all sort of higher order calculations. Then, strictly speaking, division and multiplication are equal level. So you can either do division or multiplication first, but what's important that they are higher order operations than addition and subtraction. So again, addition and subtraction interchangeable. Depending on which one's easier for you, you can do the addition first and the subtraction, or the other way around, but they have to come last. So in our case, we do have a bracket, so we need to deal with the bracket first. And inside the bracket, I have got addition and multiplication. So out of those two, I need to do the multiplication first. So 2 times 6, giving it away, 2 times 3 is 6. Once I carried out the multiplication, I can do the addition. So 6 plus 1 is 7. And now I know what's the value inside the bracket. And I always remember that if there's no sign in front of the bracket, that's multiplication. And then I can carry out the final calculation, and the answer will be 35. Okay, so whatever this formula was used to calculate, the final value is 35. Second, when I know that Q is equal to 10. So well, I need to remember here again that there is multiplication here. So I've got 2 times 10 squared minus 4 times 10 plus 150. I don't have brackets in this scenario. So the next is the other operations. And I do have a higher order operation in here, the square. So that's the one I need to do first. So this will be 2 times 100 minus 4 times 10 plus 150. Now I have got only multiplication, addition and subtraction. Out of those, the multiplications are the higher order operations. So I have to do 2 times 100, 200, minus 4 times 10 is 40. And now I only got additions and subtractions, so I can do them whichever order it pleases me, whatever is easier. So you can do 200 minus 40 plus 150, or you can do minus 40 plus 150 plus 200, or you can do 200 plus 150 and then finally the minus 40. All going to give you exactly the same answer, which is, what is the answer?
310.
Okay? Now again, if you have got the scientific calculator, that is a very good aid, because you can just type this expression into the scientific calculator straight away, and the scientific calculator follows Bodmer's rules. With ordinary calculator, you would have to tell the order operations, because the ordinary calculator carries out calculation in a linear fashion. So whatever you tell the calculator first, it will do that calculation first. So if I type it into an ordinary calculator, I'm not going to get the correct answer. Because what it will do, it will times the 10, and then whatever the answer to that, it will square it. Then take away 4, multiply that by 10, and then at 150. That's certainly not what we're doing here. But the scientific calculator carries out the operations in the correct order. So that's why it's very useful to know how your calculator works. Okay. So the last example, I have got t equals square root of, oops, I forgot the 2 pi. Square root of L over G. Now, has anybody seen this formula before? What is it?
No, I just remember.
What is that, period?
Yes, it's the period of the pendulum.
Yeah.
Okay, so how long a pendulum takes to swing from one end to the other. Okay, good old physics lessons. Now, I have been given the value of L being 1.4 and G being 9.8. How about pi?
3.1.
So you need to remember that pi is a special number, and that's value is 3.14 to the nearest 2 decimal point. Now your scientific calculator stores the value of pi to 10 decimal places, so if you want to be very exact, you can actually use the calculator to call the pi number up, and then you will get a more correct, more exact answer. But quite frankly, 2 decimal places is a very good approximation. So what I need to do in here is 2 times 3.14 times root of 1.4 over 9.8. Now, with these calculations, what do I need to carry out first?
There's no brackets, those other operations.
Yes. So I've got the other operation, which is the square root, but under the square root I have got a division. So before I can take the root, I need to carry out the division. So I carry out the division, then I take the root, then I multiply that by 3.14, and I multiply that by 2. I'm not going to do that because that is not very fast to do. But if you have got a scientific calculator, you can cheat. So you can type in 2 times, and then I can call on the pi, which is on my calculator is shift that times 10 to the x, which is the right middle at the bottom. And then on my screen is just 2 times pi. And then I need to put the times in again, and then I have the square root button. And under the square root button, I can press the fraction button. And then I can type in 1.4 to the top, use the arrow, come down, type in 9.8, and I can hit equal. And the exact answer to 2 decimal places is equal to, oops, I picked up the wrong pen, 2.37. Okay? Without the scientific calculator, it would take us quite some time to work it out. But in most cases, that's not what your teacher wants to test you. They want to test you how well you understand the concept behind to demonstrate the calculation. So that's why you are allowed to use the scientific calculator in most situations, unless you study mathematics. Certain areas of mathematics not really designed for the calculator use. Okay. Now, this is a more common business-like example. Those of you who study business, what is this formula used for?
Interest?
Yes. What kind of interest?
Compound interest?
Exactly. So it's basically how to calculate compounded interest. Now, FV stands for future value, PV stands for present value, R stands for the rate, and N stands for the number of years. And that's the very commonly used future value formula when you have got a compounded interest. This specific compounded interest is for the yearly compounding. Now, why do we have it over 100? Because our rate is usually a percentage. So I've got 2.7% interest every year, which is literally nothing, because it's usually the inflation is around 2%, so might as well just spend the money now. So future value equals present value times 1 plus R over 100 to the N. So I know that I have got £1,500 and I've got 2.7% interest on it, and if I put my money away for 5 years, how much money am I gonna get back? Now again, doing this calculation by hand, we could stay here for a long time, simply because raising something to the 5th power on a piece of paper would involve quite a lot of calculations. Luckily, I believe none of you have been taught how to do that by hand, because I grew up with the calculators, so we have always used the calculators. I assume that you have too. But before the calculators have been invented, people were taught algorithms how to calculate higher powers. And that was, no, you might trust me, wasn't very handy. However, scientific calculator changed things quite a bit. So what's important in here? You type in the 1,500, then you type multiplication sign, you open the bracket, press 1 plus, you press the fraction button, put the 2.7 on the top, come down with the arrow, put 100 at the bottom, come out with the arrow again, close the bracket, and then what you want now, you want to press the any power button, which is basically this button on most scientific calculator, X with a little box in there. And then into that box you can type in the 5. And then just hit equal. And that gives me 1,713.73 pence. Okay, a whopping £213 after the bank made use of your money for 5 years. So again, something to think about. Does it worth to putting your money away for so long, or would you have a better value if you just spent it right now? Okay. Any more questions, or any questions whatsoever? Okay. As I said, it's really good to become very familiar how the scientific calculator works, because that's going to save you a lot of time in an exam. Now, this was when we needed to calculate values, given values for a formula, but sometimes you have to rearrange those formulas. So how can we do them? Make Q the subject of the formula. That is basically rearrange the whole formula, so X is on its own on one side and everything else is on the other side. Now what's going to happen in here is that we're going to undo what BODMAS does. So we're actually going the opposite direction. So we're not going BODMAS up down, but down up. So we deal with additions, subtractions first, then multiplications, divisions, and then anything higher. So the first one, P equals a third Q plus 5. By the way, what kind of formula is this if you study business? What is this one? It's price and quantity. So this is the inverse demand function because it gives you the demand, gives you the price as the function of the demand. The demand function would be Q equals, which would give you straight away the demand is the function, demand is the price.
This would be what we're finding there?
Yes, that's what we're going to do. So we're changing inverse demand into demand,
So
which
it's
is
the inverse of demand.
yeah. So you usually calculate them one from the other, because in certain situations you need the demand function, in other situations you need the inverse demand function. So, as I said, we're undoing BODMAS. On this side, I've got division and addition. How do I undo addition? Subtraction. So P minus 5 will be equal to a third Q. Because now that 5 I've taken away. 5 minus 5 gives me 0. So that's how that 5 disappeared from this side. And whatever I do to one side, I have to do to the other side as well. So that is that's how the minus 5 appeared in here. Another way sometimes is being taught that if you want to take something away onto the other side, it becomes the opposite of that calculation. And because we had plus 5 here, the opposite of that will be negative 5 on the other side. Depends on how you've been taught. The end result is always the same. And now I've got 1 over 3, which is basically dividing by 3. To undo division, I need to do multiplication. So I need to multiply both sides by 3. So 3 times P minus 5 equals 1Q, which is Q. And probably you want to remove the bracket because that would help you to see easier the connection between the price and everything else. Okay, so that's how you rearrange the demand function. In the second example, I've got y equals 6x squared. Now I need to rearrange this formula to have x on its own on one side. When I'm looking at BODMAS, I'm coming up from the bottom. Addition, subtraction, division, multiplication, and the rest of it. I have no addition, subtractions here, so I need to deal with the next tier, which was multiplications, divisions. Well, I do have that, so I will need to divide down both sides by 6 to remove the 6 from front of the x squared. So I've got y over 6, that is equal to x squared, but I'm not interested in x squared, I'm interested in x. So how do I undo the square? By taking the square root. So x is equal to the square root of y over 6. But not just simply like the square root, I need to put the plus minus in here. Why? Because minus 3 times minus 3 gives me positive 9 the same way as 3 times 3 also gives me positive 9. So whenever I undo the square, I always have to put the plus minus in there because it usually gives me 2 solutions. Now, if instead of y's and x's, I was working with prices and quantities, would I have a negative here? Can I have something like minus square root of p over 6 equals q?
No.
My quantity then would be negative. Can I have negative quantity? Selling negative numbers of goods? No.
Well,
Because that would mean I'm giving them out for free, or
They were stolen?
they were stolen or something. Yeah, actually, that's probably the only situation when you would be using it in your balance sheet if something has been lost or something has been stolen. But other than that, quantity is always positive. So in the practical scenarios, there can be situations when you don't have to worry about the negative. But in mathematics, it's always plus and minus. Okay? And the last one is probably the scary one. Because I have to dig all the way down to make G the subject of the formula. Now, G is under the root and at the bottom. So, first of all, what I need to do, I need to remove the multiple. And the multiple to remove is divide down by it. So what I'm going to do is t divide down by 2 pi. That is equal to root L over G. Now, the G is under the root. How can I undo the root? Well, I've undone the squaring by taking the root, so I can undo the root by taking the square. So, that would be t over 2 pi squared equals L over G. But now I want G, and G is at the bottom down. So what I can do, I can multiply up by G. So I would have G up. But in this way, I have got L as the subject of the formula, so I haven't finished yet, because I need to remove all this from this side. So what I can do, I can divide down by this. So G will be equal to L over T over 2 pi squared. I can leave it like this, or if I know a little bit about powers, which you actually haven't gone into yet, but we're going to come to in a minute. This is two numbers divided by each other, and each of them raised to the same power. I can actually break that bracket up, and I can say that is L over T squared over 2 pi squared, which is again a multiple can be squared by squaring the individual terms. So that can be G equals L over T squared over 4 pi squared, because 2 squared is 4 and pi squared is pi squared. And now what I remember is that when I need to divide a number by a fraction, that's the same as multiplying by the reciprocal of the fraction. So basically, that G is equal to L times 4 pi squared over T squared. And remember the reciprocal, 2/3 reciprocal is 3 over 2. So you just flip the fraction upside down. So if you ever had to carry out something like 2 over 3 divided by 6 over 5, to do that, you would do 2 over 3 multiplied by 5 over 6. And then that gives you 10 over 18. Numerator by numerator, denominator by denominator. And then both of them are even numbers, so I can cancel it down by 2, half them each. So that would give me 5 over 9. So that would be the simplest form solution to this division. Little crash course on fractions. And that's basically what we've done here. Trip this one up. And then that's probably simpler and easier to understand than this one. Because then now you would see that actually the pi contributes to the growth of G rather than making it smaller. Okay? I have no idea how complicated formula you need to work with, because it can get a bit more complicated. But I'm not going to go there today. Okay? Now, what I've got here is almost like an equation that is all over the place. But what I want now, I want to express x in terms of y. What that tells me is that x have to be on one side of the equation, and every term that contains y and everything else have to be on the other side of the equation. So I need to collect x's on one side and put everything else onto the other side. At the moment, x's are on two different sides. So what I'm going to do first, is pick a side, doesn't matter which one, and I'm going to collect x's on that side. So do you want to collect x's on the left or the right hand side? Makes no difference. Okay, we're going to collect it into here. So then I've got x already here. The cx is on the other side, so I need to take it away. And this is minus ay, so if I move it to the other side, I've got ay plus y, because the plus y was already here. In that way I separated them, and x is on one side. But unfortunately, it's x minus cx. So what I need to do now, I need to factor the x out. But if I factor x out from x, what the hell do I left with?
1.
Just the 1. So it's 1 minus c equals ay plus y. And now I just need to divide down by the 1 minus c, and voila, x is expressed as a function of y. But what I also spot is that actually y is a common term in the numerator. So I can actually do one step more and say, okay, this is a plus 1 times y over 1 minus c. And that could be useful, because if you wanted to compare how does x changes depending on the different values for a and c, in this scenario you might see it easier than in here. Because in this case, as a gets bigger and bigger and bigger, that's going to give you a higher value of y. But if c gets bigger and bigger and bigger, that's going to end up being negative and a very small number. So that's going to have a different effect on y change. And that's, again, overall, will give you a different effect on how x changes. So probably easier to see in this format what's going on than in this format. I still have the same goal here. I need to express x in in terms of y. That's nice and simple. Unfortunately, this is y expressed in terms of x. So I have to undo the whole thing and collect x's on one side and see how that does depend on y. So what I'm going to do here, x is both numerator and denominator, so I'm going to multiply up by the denominator. So that will give me y times x plus 4 equals x minus 2. But now x is hidden in the bracket, so I need to multiply the bracket out. y times x is the same as x times y. Y times 4 is 4y. Now what I've got is, now I have got terms which only contains x, but they are on different sides. So again, I need to collect them to one side. So xy minus x will be equal to 4y needs to go to the other side, so that will be minus 4y minus 2. Now I can factor out the x because I want x on its own. And then I can just divide down by the y minus 1. So x is equals minus 4y minus 2 over y minus 1. And that is x expressed in terms of y. So the key was here is that I had to undo the division first by multiplication, then break up the bracket, then collect x's on one side, factor out, and divide down. And again, now if I have got different values for y, I would know how that y changes would influence my x. If y would go, let's say, if y would be positive 2, then I would be able to see what would the final value for x. But from here, I would not be able to see it. I would pretty much have to go through the same manipulations, but knowing now that y is 2. Any question? You are not a chatty lot. So, well, I've got here again the good old demand functions. So let's try to rearrange them. But now what we got here is so-called parameters, because instead of given numbers like 2s or 3s, now we have got letters. These are the generic way of manipulating them. So if I would be given a specific value for A and a specific value for B, I would be able to do that for every single different values rather than having to go to the manipulations each time. So maybe I should change pen. So Q equals AP plus B. So I want P in terms of Q. So what I need to do, I need to take the B away, because that's in my way. So Q minus B equals AP. And AP means A times P. So to undo it, I need to divide them by A. So then I have Q minus B over A equals P. And for every specific AB values, now I would be able to substitute just back into here instead of substituting into here and having to go through the same manipulations again. In 2, that's a slightly different version, because P is now down at the bottom. First I need to bring it up into the numerator. So first I need to multiply the whole thing by AP plus B. So Q times AP plus B equals 1. Now, instead of breaking at the okay, I'm going to break up the bracket, because I think in that way I'll be able to manipulate it into a more meaningful form. So it's APQ plus BQ equals 1. Now what I want to do, I want to remove the BQ. So it goes to the other side, becomes negative. And I want P on its own, so I need to divide them by both A and Q. So then P will be 1 minus BQ over AQ. I could have divided them by Q here, take away B and divide them by A, but then I would have ended up with a fraction on top of a fraction. And that's a little bit more difficult to see. If you're familiar with fractions, you probably would have been able to rearrange it into the same form, but might as well easier to go this way. If it was just numbers, that would be no problem, because then you would 1/3 take away a number gives you another number, divide by another number gives you another number. But with the formulae, when you have got the parameters in there, sometimes one way is a little bit more meaningful than another way, or easier to manipulate it into a more meaningful format. Unfortunately, that comes with practice. So not always see straight away which way would give you the easier answer, the same answer in an easier way. Because thankfully in mathematics, doesn't matter what route to take, as long as you follow the rules correctly, the answer is always the same. Not all subjects are like that.
That's true.
Hold on, I think I pressed the wrong button. Yes. No, I didn't press the wrong button. It's a version of the same thing we tried before, but with a twist. Because now I need to find the rate. When I know the future value, the present value, and the number of years. So I know that the future value was, my future value is 5,600. I know that I invested £1,500 at some rate 5 years ago. The question is, what was that rate? So how can I get into there, right in the jungle, right in the middle of that formula? Well, there is a division, there's a multiplication in here by 1,500. So first what I'm going to do, I'm going to take the 5,600 and divide that by the 1,500. And that's going to just give me this one. And thankfully, I've got the calculator. 5,600 divided by 1,500 gives me an unfortunate 3.7333 recurring. So I'm just going to keep it simple, but that is equal to 1 plus r over 100 to the 5th power. How do I undo the 5th power?
Square root.
Not square root, 5th root. 5th root. So I'm taking the root, but I need to take the 5th root. So, on the scientific calculator, you have got a button, but that's in yellow on mine, where you have got this. And that is what you need to call on to get any roots. So I need to press Shift, that button, which is directly on top of this button. And I need to press 5 into here. And then I need to come down, and I either press the 3.73 or I use the fact that the scientific calculator automatically saves the last calculation into the so-called answer memory. So if I press A and S, I can actually just recall the more exact answer for this division, rather than just putting in the rounded answer. And that's going to give me 1.3 1.30 to 2 decimal places, because the actual number is 1.30142556, so 2 decimal places is 1.30. And that is equal 1 plus r over 100. What do I need to do next? I need to take away 1. So then I end up with 0.3. That is r over 100. And then, to get to r itself, I need to multiply by 100. And that 0.3 times 100 is 30. So, if I had £1,500 and I put it away for 5 years and I ended up with £5,600, that means that I would have had a very, very, very generous 30% interest rate on that investment, compounding for 5 years. And if you look at the two values, that's not such a huge amount of money that you earned over the 5 years, but that's already a very huge interest rate. You look deep in thought. No? because sometimes these numbers, you look at them and they just, do they make sense at all?
Well, at first I was wondering, like, if we're solving for r, and that's essentially the rate, but we divide by 100 because we're looking, essentially, r is in terms of a percent.
Yes.
At first it wasn't clear, but then I was just thinking about, like, is that really, I don't know, good if you put it away 1,500 pounds or whatever, and 5 years later you get 5,600, whatever. That was more of a personal deep thought.
Oh yeah. Well, it really depends on if you have got money that is actually, I mean, your bank never going to give you this.
Exactly, yeah.
So your bank never going to give you this. This is more about some kind of investment into something that yields more money. But that's usually comes with a bigger risk, and you might not get that money, but that's, you know, this is the mathematics behind it, and doing the risk is a totally different way, and for that you need to be aware of more statistics rather than just simply mathematics. There's a lot of statistics in risk and risk awareness and all sort of things. So that's for a totally different lesson. Okay. Last part of today is laws of exponents. Now, we already touched on it when we talked about a squares and x squares and the rest of it, but there are a lot more rules and definitions that we need to know as soon as we start to work with the exponents. Now, first thing is, just so you know, mathematics is so clear, there's nothing ever anything misleading or complicated. However, in some scenarios we use 3 words for the exact same concept. So anybody who tells you exponents, powers, or indexes, they all mean the same thing. You've got a number multiplied by itself a given number of times. And how many times you multiply it, that will be your power, your index, or exponent. However, we need to be clear on some definitions. Any number to the zero power have to be equal to 1. Doesn't really make sense, because how can I multiply something by itself 0 times? But we have to start with this definition, otherwise the system doesn't work. So a to the 0 is 1. Any base to the 0 power is always 1. Now this one makes a bit more sense. I'm multiplying the same number by itself once, literally haven't done anything to it, so that is just the same number. This one is slightly more difficult, and that's not necessarily a definition, because you can actually derive that if you know one of the other rules, which is on the next slide. So I'm going to come to you in a minute and I'll show you how you can derive this when we cover that rule. But this one, what I need to remember is that the roots and the powers are exchangeable. So the nth root is the same as the 1 over nth power. And if I have got the mth root, something raised to the nth power, that is a to the n over m. So obviously n has to be in the numerator, because you're still multiplying a by itself n times. But m, which was the root, we defined it as the bottom in the fraction. So that's why it has to come into here. Now, these three are definitions. This is a kind of special case of that. And this one is not necessarily a definition because I didn't bring those ones up. Because if I remember that a to the n over a to the m is equal a to the n minus m, I can apply that to the special case of a to the minus n. Now a to the minus n is nothing else but a to the 0 minus n. Then that can be written as a to the 0 over a to the n because of this rule. And I know that a to the 0 is 1. So strictly speaking, that's not a definition. I can derive it as a special case of this rule. But it's just handy if you remember straight away that a negative power is just 1 over the positive equivalent of that power. Sorry, I'm losing my voice. So let's apply these rules. And I've just noticed, what happened to my slides? I'm missing a slide here in between. I must have accidentally cancelled it. Right. Before we can go to the practice questions, I need a few more rules, because otherwise I can't work. So a to the power of n times a to the power of m, that is a to the power of n plus m. Okay? Now, why that works? Well, a to the n is nothing else but a multiplied by itself n times. And a to the m is a multiplied by itself m times. So altogether, how many a's do I have? N plus m. So that's why these two are absolutely equivalent. They're absolutely the same. Now, the other one, which I just drawn, is the difference. Now, why is that? Because what I've got here is n number of a's at the top and m number of a's at the bottom. So from the top, I can cancel down all of the m's. So one by one, I'm taking them away. So altogether, I've taken m number of them away. So now I'm only left with n minus m number of a's. So probably easier to see if I had a to the 5 over a to the 3, then that's 1, 2, 3, 4, 5 a's over 1, 2, 3 a's, and not 9's. And I can cancel down one by one. How many I've taken away? 3. So I end up with a squared, which is actually the difference between 5 and 3. And the last rule, if I raise a power to a power again, that is the multiple of them. Because what's going on in here in the general case is a to the n times a to the n times a to the n m times. And then what I can do, every single one of these a's, I can break out n times, and and I have it again, n times, but remember that altogether I had m terms of these. So altogether I have n times m a's. So if we look at that for a simple number, 2 to the 2 to the 3 means 2 to the 2 times 2 to the 2 times 2 to the 2. But each of these is 2 times 2 times 2 times 2 times 2 times 2. So first, second, third. Altogether 1, 2, 3, 4, 5, 6 of them. And that is the multiple of the 2. Okay, powers are not difficult, but you have to remember all the different rules if you want to work with them quickly. You can always think through what does the definition mean, how can I work this around, but if you know the rules, the work becomes a lot faster. So I'm actually going to keep these rules up here because that slide has disappeared and that's annoying.
You'll have the full slide deck on Moodle.
I'm going to have to because I can't deliver this workshop with that missing slide again. Okay, so number 1, 4 to the 2 times 4 to the 5 is that rule. Same base multiplied by itself, so that gives me 4 to the 7. Number 2 is this rule. The same base divided by, so that will be 3 to the difference of the powers, which is 4. Number 3 is this rule. I'm raising a power to a power, so I need to multiply the powers together, so that will be 5 to the 12, because 4 times 3 is 12. Now number 4, if you don't remember, it's on your slides. A negative power is 1 over the positive power. Number 5, again, if you don't remember, is on your slides. A fractional power is a root, but now what root is it? Is it root 2 or is it root 3?
2 or 3.
The denominator is the root, the numerator is the power. So it's cube root 2 squared. 6. Now that's a little bit different now because I have got a negative and a fraction. So I need to decompose it, and I usually best to do it in 2 steps. First deal with the negative. The negative means that it's the 1 over the positive power. And the fractional power means that this will be a root. Again, which one is the root? The 3 or the 5? The 5, because that's at the bottom. So 5 and the 3 stays here. 7. A to the 5th times a to the minus 3. Well, I've got the same base. That's not a number now, but I know the base. That is same. So I'm multiplying them together. So that is this case. So all I need to do, add together 5 and negative 3. 5 and negative 3 added together gives me positive 2. I've got b to the 7 over b to the 3rd. That is this rule. So it will be b to the 4, because that's the difference between 7 and 3. 9. X to the 15, because that's this one, power to a power, multiply the 2 numbers together. And the last one, now that looks a little bit That looks a little bit funny.
So 2 over 5.
2 over 3 to the minus 2.
2 over 5.
Oh, 2 over 5. I can't see. So 2 over 5 to the minus 2. Now what I know about the negative power is that makes it 1 over to the positive power. Now 2 over 5 squared is 2 over 5 times 2 over 5. How do I multiply fractions together? Numerator times numerator. Numerator times numerator, denominator times denominator. But 2 times 2 gives me 4, and 5 times 5 gives me 25. But that's also the same as 1 over 2 squared over 5 squared. And how do I divide by a fraction?
Multiply the reciprocal.
Multiply by the reciprocal. So that will be equal to 1 times 5 squared over 2 squared, and obviously anything multiplied by 1 is just itself. So if you have got a negative power in a fraction, effectively all you do, flip the fraction. Because I ended up with 5 over, so that's 5 squared over 2 squared. I ended up with flipping the fraction. Okay? And that's it. And I'm proud because I'm on time.